So I'm Schuyler Bishop. I work for a company you may or may not have heard of called ThoughtWorks. If you haven't heard of it, I'm sorry because you're missing out on a great thing. ThoughtWorks has been around for since I think the late 80s, early 90s. Originally founded in Chicago. It's got a couple of people in it that you've heard of. One in particular, this guy that you might have heard of, Martin Fowler. It turns out he's sort of well known in the software industry for some things that he wrote about, some sort of a manifesto or something like that. I'm kidding, of course. Martin Fowler is a great writer, speaker, thought worker. He has a fantastic blog. If you've never read it before, I'm going to be quoting from some of his work. That he actually borrowed from the teams that I work on, which is called Digital Platform Strategies. So let me get into that. Let me share my screen. And give me a thumbs up, Pete, if you can see this. Good? All right, thanks. So the art of platform thinking. We're going to go into this it's kind of step-by-step through this. As I said, I'm Schuyler Bishop. I'm a delivery infrastructure SME. We're going to talk about what delivery infrastructure is here in a little bit, in our opinion. But I'm also a principal consultant with Digital Platform Strategies for ThoughtWorks. That's a mouthful. So we'll talk about all of it. All right. So here's the plan for today. This is what we're going to talk about. What is software delivery at speed, and why do we need to deploy so quickly? What is a platform? Why do I need to think in a platform? What is platform thinking, and why should I think that way? What does delivery infrastructure do? And then a round of questions. And my intention is to have this about a 30-minute talk. And so I'm going to try to fly through this fairly quickly, and then we'll have questions at the end. I will say that if you want to, I'm totally fine with people interrupting. I would ask that you use the if you mouse over your name and the participants, you can, raise your hand and things like that. So, please utilize that aspect if you have a question. And just remember to be on mute if you're not talking, just so that everybody can have a good time here. So software delivery at speed, what does this mean? So this is a book that I hope that anybody who's a software developer has read. And if you haven't, you really should. And so it's this book right here, Accelerate, which you can't see because my virtual background. There we go. It's got a foreword by Martin Fowler, again a thought worker. Gene Kim, if you know him from, of course, the Phoenix Project, which I have up on my shelf, and now the Unicorn Project fame. And Nicole Ferguson, Foss Green, screwed that one up, and Jez Humble. Who did some fantastic data work in the book. But what they found when they crunched the numbers is that high performers have a very unique amount of deployments and such that they do. So a high-performing organizations deploy multiple times per day versus a low-performing team, which is once a week to once a month. Now, if you deploy once a week to once a month, that doesn't necessarily mean you're a low-performing team. If you're doing that for a different reason other than the lack of a capability. So like if you couldn't possibly deploy more frequently than once a month, then that might suggest that you might be a low performing team. And that's not like a terrible thing. You're in very good company. I think that if you look at the bell curve, most organizations are right there in the middle, of course. It's a fairly normal curve. And so you'll see that, most organizations are somewhere between. But multiple times per day is actually a really difficult thing to get right. If you think of what has to go into deploying multiple times of the day, you have to have a very strong test background. So you have to have unit tests, you have to have integration tests, you have to have QA that's fully automated. You have to have infrastructure tests that are baked into things to make sure that you don't have drift in your environment. So there's a lot involved in that. So it's really hard to do. Lead time to changes is less than 1 hour for high-performing teams. That's amazing if you think about it. It could take a team less than an hour to make a change that could get all the way to production. Pretty cool. And then high performers also had an MTTR, which is mean time to repair, of less than 1 hour. And this is a crazy thing, versus 1 day to 1 week for some of these other teams. And if you think of a 1 week MTTR and you take your application that is being used by customers and imagine being down for a week, that just blows my mind all by itself to think of that situation. I try to think of the worst outage I've ever been a part of, and I don't think it was a week. I think the biggest I've ever seen is like a 48 or 72-hour outage when everything just broke all at the same time. High performers also have a change failure rate. By the way, these are called the 4 golden signals in Accelerate, if you're not familiar. Again, great read. But change failure rate means that if you push a change, does it create an outage or does it create a failure in that change itself? And this tends to focus around how many tests this software product has as its environment. But high performers have a rate from 0 to 15%. So there are some high-performing teams who have a 0% change failure rate. And then the low-performing teams are 31 to 45. All right, so what is fast software delivery and why do we want to do it? So we've said what the things are that can define a team that is a high-performing team. But why do we want to do that? And the simple reason is that it generates significant value for organizations. In general, the organizations with high-performing teams are twice as likely, 50% as likely to exceed their own goals versus low-performing organizations, which are 50% as likely to not meet their goals. And that's a huge shift if you think about an organization. So these are things like revenue, profit, sales, dividends, tangible value for this organization that comes out of these high-performing teams. And so what are some of the keys to high performance then? Well, software developer experience plays a part. If you're not familiar with the term developer experience, that is, I simplify that to mean the amount of friction that a developer encounters while trying to do anything outside of the normal. And if you think of that statement, that's usually a very telling thing about an organization. As a developer, if you wanted to innovate, how difficult is it to you to get that innovation into production? And how many manual steps does it take in between? That's a key piece of DevX. A software and an API architecture plays a big part. If you have a gigantic monolith, you're probably not going to deploy it more than once a day. You're probably not going to deploy it more than once a week, or maybe, like you're getting towards that, once a month even. And that is because monolithic code bases tend to have large amounts of change. The batch size in work that's done in a monolith is usually much larger. If you look at what we call the thin slice at ThoughtWorks, which is the smallest amount of work possible, and you're doing those thin slices in a microservices model, each change is really small. And so when you deploy it, you can rapidly determine where the change failure was occurred to, what part of that deployment caused it and such. So architecture plays a huge part of how you can be high performing. Self-service data. So what's another common monolithic pattern in the industry? It's the database. If you have a single database and that's how you're integrating your entire application together, that database is a monolith. That might work fine for you and you might want it that way, and that's fine too. I'm not judging in any way, shape, or form you, but teams that have high performance have individual data stores for each application and they integrate through their APIs. And that's a key concept. Again, it works back into the software architecture. But if you have a product that integrates through a database, that database now has become your monolith, just like the monolithic application could be before. So self-service data plays a part because we want these teams to own their own data. Already talked about small batches, how important that is. Trunk-based development is a big deal. If you're not familiar with trunk-based development, it means that you push to master always. You don't typically branch at all. If you do branch, these are very short-lived branches of a couple hours at the most. If you've worked in this system, it's magic when it works. And if you've not worked in it before, it's terrifying to think about it. Most people are used to interacting with master through pull requests, which creates what I call a meat gate or a human gateway. And so we want to get rid of a lot of those and have, instead of human gateways, we want to have code quality checks. We want to have unit tests that surround it so we can tell when a change in a unit breaks it, and it doesn't make it into any of the environments, it gets caught at testing time. So small batches and trunk deployment. Automated wide coverage testing plays a huge part. And it's funny because if you look at each of these bullets, they're all small parts except for testing. Testing's a big deal. Your test coverage, which, return, return true is not a test, but your test coverage plays a big part in how successful you are at deploying software. But if you think about the things that tie all these concepts together, what's the first thing that you have to get right? Well, it's the delivery infrastructure. How do we create software? What are our pipeline capabilities? How do we orchestrate those software deployments? And then how do we have automation surrounding all of that? And then finally, how do we make all of that self-service? And that's what we're going to talk about, and that's my job at ThoughtWorks. Any questions here before I move on? All right. So what is a platform? This is a slide that my manager, Ryan, put together. Ryan is I guess he's the director of digital platform strategies. I've got some links at the end here, and I'll have this deck where Pete can share it out as a PDF, and you can see those links. One of the links is Ryan's view on how the art of platform thinking, which was a lot of the foundation for what I've done in this talk today. We theorize that there are 5 elements of as a blueprint towards a digital platform. Delivery infrastructure, we've sort of been talking about that already. This is how we deliver software faster. What is elastic infrastructure? That means it's self-healing. That means it's self-scaling. CD pipelines, true continuous deployment, trunk-based. Security, deployment, runtime monitoring, all those things are all baked into that. And we want all of those to be self-service. I'm not going to focus a lot on the other areas, but we already talked briefly about API and architecture remediation. Self-service data was already spoken of, super important stuff. Experimental infrastructure and telemetry is an interesting point because that's things like canary deployments, blue-green. How do we have instrumentation inherent in our system? This could also be called observability in a lot of ways. If you look at the ideas that are going there, all this concept, the difference between observability and not observability is a mathematical term if you're not familiar with it. And the definition of observability, if memory serves me, is that it is how you measure a system from the outside of it. And then finally, the customer touchpoint technology, which is how do you make sure that you're constantly getting feedback on your product. So I want to throw the slide out there just because it's a little bit of ThoughtWorks marketing, but it's actually some good information on it. All right, and so what is a platform? Now, I've quoted Mr. Fowler here, and I've got a link to his blog post that talks about this at the end of the speech, but a platform is self-service, it's composable. That's a really key and cool part of what a platform is. I talked about that briefly already, where I mentioned the fact that you shouldn't be integrating at the database level, you should be integrating across your APIs. So publish an API spec, have AAA surrounding your APIs so that other teams can get tokens and interact with your APIs because they have their API specs. This is part of this platform concept, is having those defined clear boundaries that dumb pipes, smart endpoints. Platform does not force an inflexible way of working on the delivery team. We want to be opinionated, but we don't want to be inflexible. So if you're a team that is hell-bent on using Node, there's nothing wrong with that. But we want to be opinionated and say, okay, we're going to primarily support Java 13 or whatever it may be that's the primary platform support. But we're going to allow you to run your own workloads on here that aren't Java-based, but just realize that you're not going to get a lot of direct support that other people in the platform may get. So for example, one of the early wins that you get in a delivery platform is something called a starter kit, which is a Hello World app that's instrumented, contains monitoring by default, contains a pipeline that's fully all the way to production and has all the rights to deploy to production, and has any other integrations that application would need. So the way that we do that is there's a command line interface that we created called dpctl or dpcontrol, dpctl, and one of the commands in that is microservice create. And when you do that, you get a directory with a Git repo, with a Hello World app, a pipeline, all those things instrumented and everything else like that by default. So you see this very opinionated way of doing that. You can toss all that away and start yourself. So it's not going to limit you, but it gives you a head start on it if you want to use that. Platforms are quick and cheap. And I think that's a big cue here is an easy on-ramp. In other words, the quick start guides like I've just spoken of, documentation and code samples. If you have something that you can pull down and then almost immediately have in production, even if it's a Hello World tracer bullet type app, that's a very powerful tool. Think about how many times before you've had to stand up a new service. You got to go create a Git repo and you got to request that through some request process. And then you have to go in and you have to request environment access. And then there's SSH keys involved and blah, 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 and so on and so forth. If you can simplify that process to a single command that drops everything and it's instantly usable, that's super powerful because it gets rid of a lot of the churn and waste that happens for a lot of teams. Has a rich internal user community for sharing. We call those communities of practice. So this is other developers helping developers, basically. Another good kind of key concept that happens a lot is the concept of an enablement team. Site reliability engineering as a practice is very positive on the concept of enablement teams. And I have a couple of books that I can suggest on this. One is called Team Topologies, fantastic book if you're looking for another read. So I've already listed Accelerate and now Team Topologies. Team Topologies talks a lot about Conway's Law and how you can change your team compositions to fit how Conway's Law works in software delivery. Secure and compliant by default and up to date. I think those are pretty straightforward. Security is one of those really hard things to do. I actually advocate for teams to create a security product that itself is an API such that other teams can call that API and use that for security-based decisions. And I'll talk about that briefly if anybody's interested at the end. This is straight from Martin Fowler. Again, I've got a link to his article. It's a really good read. So what does a platform look like to a developer? I was kind of thinking, so what would my audience want to see about it? So it's CLI-based self-service creation by the starter kit. We already talked about that. Fully instrumented, default customer controlled monitoring. So if you've ever been in an environment where you have to go to a monitoring team, that's an anti-pattern. There's nothing wrong with monitoring teams. We advocate that developers should own their code all the way through to production, and thus should also have full control of monitoring all the way through to production. So if you think of yourself as a developer that owns your code, you have to support it. How do you make sure a problem doesn't happen again? Well, you either add a test for it or you add monitoring for it. Normally, you would have had to go to another team. You'd have to explain what you want. You have to wait for a little while for it to be done. We say that teams have this context themselves. Let's give them self-service monitoring. We do that through Terraform and Datadog in a lot of situations. Honeycomb plays a big part of that in a lot of situations too. Both great tools. Self-service, non-monolithic data sources. We already talked about that. So, again, only interact via APIs between disparate products. Pipeline as code. Now that's something that a lot of people are familiar with Jenkins. Jenkins is great. I really like Circle CI as a product personally, because you don't have to mess with it. It's a software as a service. You don't set up workers. You don't set up any of those things. It's harder to integrate in some situations because it's outside your network, and so you have to build some of those inward integrations to tools that sit on inside your network and are protected. But you don't have to manage any of the workers, and all you do is use it. So it takes a lot of the thought out of that, which is kind of nice. So that's pipelines as code. Pipelines as a service is another interesting concept. If you think about the starter kit that I've been talking about, if you get a pipeline by default, that's a very opinionated way. So we do things like we include nightly Veracode scans in our pipelines, and we do on-demand SonarQube scans, and it includes deployment steps all the way for every single environment. And these are just namespaces in Kubernetes, but it includes deployment steps in the pipeline by default all the way to production. So if you wanted to, you could get your Hello World app and deploy it to production. You couldn't share it to the world, of course. It would only still be an internally accessible only production app, but theoretically that could happen in 5 minutes. Security checks and enforcement built into the pipeline, that's a really nice feature. If you've ever had to deal with manual security efforts where they had to scan it and then you had to go into meetings and you had to kind of negotiate negotiate remediations or whatever it may be. It's a real pain in the butt, and it really slows development down. End-to-end encryption by default, fully orchestrated and automatic disaster recovery. That's actually pretty easy in Kubernetes if you have a cluster that spans multiple availability zones or multiple regions in AWS, which, by the way, EKS does by default. All you have to do is have anti-affinity built into it, and poof, you have multi-region, multi-AZ deployed code. Accelerators or operators. An operator is a Kubernetes concept that allows you to manage third-party things. So you could have a Kubernetes operator for S3 buckets, where instead of having to go to Terraform or some other system to stand up an S3 bucket for your application to use, you could actually just include it in your deployment YAML as an operator. That's a custom concept. So you'd have to implement an operator that did that, but you could do it all in line with your deployment YAML. And finally, this is maybe one of the most important ones. I should have bolded it, but product base with a strong technical owner, focus on the fast feedback from customers, devs. And remember, we're talking about infrastructure here. We're not talking about just software development. I'm saying as a delivery infrastructure specialist, this is what I am creating in the teams that I'm helping to lead, is they are product focused. They have roadmaps that extend 2 to 3 quarters ahead. They have clear communication. I'm a big fan of what's called the leader model in a book called Turn the Ship Around that was created by a sub-captain in the Navy. And so I try to enable the teams to have control, clarity, confidence, and the capabilities to do all these things themselves versus having to come through me. So we're trying to create a system that looks exactly the same way how we deploy software, but it's product-based, strong ownership, focused on fast feedback. All good stuff. So why platform thinking then? This is a quote, I think it's kind of funny when you quote yourself, but this is one of my own quotes. I just thought it was an interesting quote, was platform thinking is the process of encapsulating shared complexities exposed via APIs. And that's how I distill platform thinking down to a single phrase. It's not as simple as this, of course, but if you do this, you're gonna be pretty far on your way to platform thinking. It's more than that, of course, but the simple concept of compartmentalizing those complexity things, those very complex ideas, into teams that understand that complexity and expose it in a simple interface, that's powerful. And that's what I believe a platform is. And platform thinking, platforms are usually multi-tiered. Platform is typically built on top of other platforms. The classic example of this is Amazon's S3. The S3 is built on top of their EBS, their elastic block storage, which is just a disk, cloud disk. EBS is built on top of an internal team, that's the data team, so that does the actual magnetic disk, how they take all these disparate block-based devices and share them via one thing called EBS. But the internal team is a platform. The EBS team is a platform built on top of the internal team. The S3 team is built on top of the EBS team, and so on and so forth. So that's typically how you want to build your platforms. So for example, at delivery infrastructure, we have a core platform, which is Kubernetes, Istio, and identity. And then on top of that, we build the experience around that, which are the APIs, the CLI, and the web UI that our customers interact with. And so we've actually already built the platform on top of the platform. And then there's another platform that's built around that, which is the entire software delivery. One of the cool things about platform thinking is typically we used to talk about the idea of teams that were cross-functional, fully cross-functional. Like, so we, a couple of years ago, envisioned infrastructure engineers on every team who were creating their own infrastructure, managing it, deploying it themselves. And what we realized was that's fine for small companies and maybe even medium-sized companies. As soon as you get a team like n greater than 5, I would say, of teams, and these are 2 pizza teams, so 6 people max typically, 9 at the absolute highest, but 6 to 7 I think is about, you want pairs typically, so 6 to 8. But I think once you get bigger than about 5 software development teams, you probably need to start thinking about how, instead of creating individual cross-functional teams, how can we take those concepts that each team has to create that's the same and pull them off into a platform? That needs to be a conscious design element of how you build it based on what your expected scale is of your teams. Cross-functional teams are fine for small organizations, though. You really need to start thinking platform once you get more than a couple teams. And speaking of silos, kill them all. Every silo should go away and build it back up instead as an API, as a product. So security is a classic silo. It's like Hotel California, where it comes in, but it never comes out in most organizations. Let's stop that. Let's reform that as itself a product. Security then becomes an API that we call that tells us how these decisions happen. And so rebuild these silos as product-focused teams developing APIs. And then think about how you do changes as an organization. Change control is one of those things too that is very poorly done by most orgs. And it doesn't actually address the issues that they're regulated for. So ITIL is a very common framework for this. ITIL is fine as long as you don't have a situation where you are trying to automate things. ITIL doesn't really give a lot of organizations the automation that they need. You can get there. So, and I can talk later after the talk if you guys have any questions on how we've solved some of those problems. But it's really difficult in a very clean, quote unquote, ITIL organization to get automated change control. And what does that non-automated change control solve? Is it adding value to the organization? Does it provide what we think it does, or are we just used to it? It's a key question there. But back to platforms. So here's some of the things that platform thinking also includes. We want to remove friction from delivery teams. That's focusing on that developer experience. High quality self-service access. High complexity behind it. We already talked about that. Create an ecosystem of technical and business capabilities. So domain-driven is a new concept inside the software development industry. It means we're not just going to throw a team together. We're going to think logically with a design focus about, does it make sense for this team to have, do they have a larger cognitive load because they have 12 different tools that they own that are not related to each other? Well, domain-driven principle says, let's think about how these tools interact with each other. And can we have one team that's got 3 and then another that has 4? And, how do we lump those together to create a team that can focus on their work versus be spread out with this very wide need that they have? Tightly focused teams. Explicitly investing in a foundation for experimentation. This is one of those key concepts to how do we become a high-performing organization. Experimentation has to be safe. You have to have guardrails around it, but you have to have that capability too. And the final thing bolded here, of course, self-service automation of common use cases. And getting towards the end here, why platform thinking? So custom software is the solution because enterprises want to react more quickly. If you've worked in an organization that has a monolithic code base, unless it's a small monolithic code base with a small team that created it, it's probably a huge pain in the butt to deploy. It probably takes hours. You probably have to have downtime. There are 12 people on a call sometimes to do these deployments. Has to be done on off times, so it's done at 2 o'clock in the morning. Monoliths bring their own problems with them. They solve some, but they also bring their own problems. So custom software for DI is the solution. Creates problems of its own, of course, because now you have upkeep. Fast software deployment delivery to take advantage of it. And then, what we were talking a second ago, change control when you deploy dozens of times a day becomes very, very difficult to achieve. And again, solid, nimble software platform, which is the base of it. Now, this is a cool graphic. This is created by Ryan. And if you look at this is the classic hockey stick graphic. The top line there is organizations that use platforms. If you extend that line to the left, what you'll find is that in the beginning, platform-enabled organizations are slower than everyone else. It takes a lot of uptake. You got to build a core set of capabilities. But as soon as that happens, every team that you add to the delivery platform actually speeds up the cadence of the overall organization because it's easier for these teams to deploy. And so you see that hockey stick where it's kind of a flat line and then suddenly it just takes off at the end. And now if you extend the everyone else line, you also see that they're slowing down over time because it's harder and harder for them to deploy, whereas platform-enabled organizations are speeding up. Last section here is, what does delivery infrastructure include? Classic question, so what exactly does a delivery infrastructure SME do? Anybody that's familiar with Office Space knows the question here, the Bobs. I use this joke all the time. What do I do? So I'm a leader of a team of about 30 engineers. We have this delivery infrastructure. It takes that holistic approach with elastic infrastructure. There's some of the tools that we list. I'm going to list them out in a little bit more in depth later. Again, custom software that surrounds everything. And one of the biggest focuses that we have is on build versus buy. We don't want to build anything that's already accessible in the market out there. We want to buy that and then customize it. So how you implement that tool is even more important than the tool choice. And I personally peer with a lot of vice presidents in larger organizations because we're teaching these other disparate teams. So security, I want to work with them to teach them how to be elastic and scalable. And so it's not just purely on the technology for what I do. And I think this is the last slide, but what is a good delivery infrastructure? Actually, I think there's one more after this, two more after this. Okay, so what does good delivery infrastructure look like? Again, we mentioned a little bit of this before, but self-service, which means 0 tickets and 0 touch. When I say self-service, that's what I mean by self-service. Literally almost 0 friction. Cloud native, we don't want you to spin up Postgres servers and have to deal with clustering and multiple zones and all that stuff. We want you to use RDS. Self-healing and auto-scaling, if you add more services to the delivery platform, we want it to scale up automatically. We don't want to have to mess with it because you decided to deploy on Friday and you added 12 new containers. We also want it to be self-healing, so we have it in multiple regions, and that's the disaster recovery by default. We want to make those build versus buy decisions that meet strategic goals of the organization, not just, hey, this is cool, let's put it in, but does it meet our value that we're driving towards? Product-driven mindset and high trust. If you've never heard of the Western organizational culture, I suggest you look it up. You will probably look at that and go, wow, that's fascinating. I had never thought of it that way, but I feel like my organization is bureaucratic or something in between. And if you look, that link down there is actually a Google link, because Google, when they talk about DevOps culture, they talk about trust. So I didn't come up with that idea. So some of the tools and solutions that we see in the delivery platform, this is Kubernetes. Probably heard of that way too much in the last couple of years. Istio, which is a service mesh, an identity provider of some sort. This can be Auth0, this can be Okta, this could be even Ping and things like that. Monitoring and observability products, which are Datadog, Terraform, Honeycomb. API, probably also some sort of CLI or web UI. We chose the CLI route because a lot of our customers are already on the CLI to write their code or to do Kubernetes work. So we have a standalone, I think it's written in Golang, CLI that we have that has an auto update function, all that good stuff, that we have all these capabilities inside of that CLI. So again, DP cuddle, service create, boom, starter kit. Infrastructure as code everywhere. Nothing is done manually. Everything is a pipeline. Everything is a test. We spin up a new Kubernetes cluster every 3 hours just to make sure we didn't break the build. We run smoke tests against sample applications, dog food and cat food, that we deploy to those new clusters just to make sure that we didn't break anything when we were pushing to master before. And so we get feedback every 3 hours on that with that new cluster stand up. Pipeline as a service, talked about that. Starter kits and accelerators, heard about that a lot. And again, key concept, automation of manual processes. This is an interesting line that some of you may be offended by, and I hope you aren't, but Martin Fowler says, I'm not ready to admit defeat just yet on DevOps. So just in case you aren't sure, if you have a team called DevOps, then that word doesn't mean what you think it means. In a classic Inigo Montoya Princess Bride moment there, you keep using that word. I do not think it means what you think it does. That's not to say that you aren't practicing DevOps, but it may suggest that your organization hasn't found your true value yet. And so you should consider how you can start to help and push your organization towards more of a platform thinking concept. Because DevOps is a practice. Just like there is no such thing as an agile engineer, there is no such thing as an agile team. There are teams that practice agile and engineers that use agile as a practice, similar to DevOps. And then cross-functional teams don't always cut the mustard. They work fine for smaller and medium-sized organizations, but it really doesn't scale. And that's when you got to start thinking of platforms. This is a funny thing. This is a real-world thing. We installed OpenShift. We're a platform. That actually happened in the client where I'm working right now. The team that works on the infrastructure side, the on-prem stuff, said, no, we're feature parity because we have OpenShift. And so we did a demo side by side of the developer experience. Their first step was open a ticket to request access to this. Our first step was start typing. So, very different approaches there. Nothing wrong with OpenShift. You can take OpenShift. It's a fantastic customization platform. If you're in OpenShift, you probably really like a lot of the stuff built into it. Good thing to mention here is OpenShift actually includes Istio now. So if you're on a modern version of OpenShift, you're already on Istio, and you may not even know it. Istio is pretty neat and also very complex. You can't buy a tool and create a platform. How you integrate it matters, not just what you purchased. So what can you take away? Here's the last slide. What can you take away from this talk? Software delivery performance correlates to business performance. Very early, we mentioned that. Focusing on one aspect of software delivery will not make you a high-performing team. You've got to look at it holistically. A good delivery platform is necessary for everything else. You want low-friction interfaces to complex capabilities so your developers don't have to worry about that. If you have a development team, they can focus on their business and how they address the business needs versus how they built stand-up infrastructure. That's not a value add for them. If you know concepts of lean software architecture, you know that removing non-value added waste is a key part of lean. The best delivery infrastructure teams are 50-50, infrastructure with development experience and developers with infrastructure experience. I think that's a key concept. SRE buys into that as well. And finally, please, for God's sake, treat your delivery platform and anything in your platform as a product. Anybody who says that infrastructure cannot be a product is wrong. And I can tell you the ways that we've created it as a product. My team has quarterly OKRs that we use. We do 6-week scoring on those OKRs. Teams have their own OKRs based on the platform OKRs, which are based on OKRs that we get from the CTO. And this was something that we created inside of the organization because it gives a clear clarity of what the direction is. But that's just one of those pieces of treating it like a product. And finally, questions.
Okay, first question. Basically, what you've described seems to apply primarily to custom application development, that is, where the enterprise owns their source code. What portions of this do you see applicable to companies or enterprises implementing purchase products like SAP or Great Plains, or you pick the label?
Yeah, great question, Derek. So SAP is a fantastic example. The organization where we are implementing the delivery platform right now is an SAP customer, a huge SAP customer. They have a massive Exadata farm. They're looking at moving that to the cloud, but SAP is still a beast. There are pieces of SAP that make sense. If you're familiar with the strangler pattern, it really depends what you want to do. So if you want to keep SAP, you're like, look, we're an SAP customer. We want to continue to invest in SAP, stay with SAP. You're probably better served on some sort of bare metal platform in that situation. If you're looking to re-platform off of SAP, in other words, you're trying to create a lot of the same concepts SAP has inside your organization, then you should consider strangling parts of it off of SAP, put interceptors in front of SAP that take and redirect those requests that you've strangled off onto it to microservices that sit into this platform. Huge monolithic applications, you really run into this problem of what am I getting from putting it into a Docker container? I've seen massive monolithic applications, you and I worked on one before, that worked fine inside of Docker. Docker does give you a lot of deployment capabilities, encapsulation of complexities and dependencies is really nice inside of Docker. Inside of a Docker container, you can take a container and run it on any developer laptop and theoretically test that out. Those capabilities are really nice. I would actually, in some cases, say if you're going to containerize an application that's a COTS application, see how it runs on a VM first. It might not make sense for you to run that inside of an orchestrator like Kubernetes. It might make more sense to just run 2 independent containers on 2 different hosts, versus you could still containerize it and buy all the benefits of Docker, but just on a vertically scalable host versus horizontally. On our side, for Kubernetes, we have very small worker nodes. So these are like 2 CPU, 8 gig of RAM worker nodes, and we just have a ton of them. And so that really limits the size of applications that can run on it, because they can't request enough CPU and memory to run these really big ones. So I see a place for containerizing, but not necessarily in Kubernetes. Docker helps, and I would just look and first consider those on VMs first.
Thank you.
Who's going to be the next brave soul? Go ahead.
Can I ask the question?
Mm-hmm.
Is this, do you see, Monolith is coming back because, a lot of microservices complexity is increasing?
I see monoliths having a place today in a modern world. In fact, I would suggest any new team that's developing a replatform or a greenfield software app should probably be a monolith first. Monolith gives you very rapid development. You don't have to, go into multiple microservices to make a change. It's all done in one place. If you have a small team and a specific purview of your application, there's nothing wrong with monolith. Where you hit the microservice need is when you start to scale that out. And so maybe you have multiple teams on the same single application. If those teams can be focused on some, this is where that domain-focused thinking comes in. If that team could be focused on a single domain, then it makes sense to have that as a microservice or microservices that serve that domain. So I think monoliths have a place, and I think that every application should probably start out as a monolith at first.
Thank you.
Sure. You should really look at how you develop that product, how you've designed that product, where the boundaries make sense, and that's when it starts to fall out whether or not that should be a microservice.
See, one of the gap I see is, any monolith can be deployed as a microservices if the architecture is modular. And you said about, if it is really separated very well with the domain. To me, the development can always be in a monolith. Only the deployment architecture should actually, the deployment scripts should change, whether it can be deployed as a monolith or a microservice.
Yeah, what does a monolith really mean? A monolith really, in the classical term, was one application that's a single code base that includes everything that application needs. So SAP is a classic example of a monolith. Behind the scenes, SAP has got some microservices going on, but the way it's deployed is as a monolith. And I think that's the definition I do. If you have a tightly coupled application, it's a monolith. If it's loosely coupled, even if it's one code base, it's still what I would consider microservices. So
but
if one part of the application,
flaw,
go ahead.
If in a monolith, if somebody is tightly coupling it, is it a design flaw? I mean,
Not necessarily.
It is a design flaw. It is a design flaw.
Is it intentional? So if you have no plan to ever expose the tight coupled interaction between your services, there's nothing wrong with that staying tightly coupled because it's internal. Nobody's ever going to need it. If you're standing up an identity provider and you tightly couple that identity provider, well, that might be bad because other people need to attach to that later. And you should have really had a concept of how they would attach through an API interface from the get-go. So it really speaks to develop the architecture and how you create the software component, the program. But there's a place for RPC. You know, Google still has services that communicate over RPC.
Sure. Okay.
Any other brave souls? Go ahead.
What do you see as an ideal microservices count in an enterprise application?
I don't think there is one. Greater than one. I think it really depends on the size of the team. Again, how is that software domain designed? How do you split the domains inside of it? How's the application composed together internally? It's really an architecture question.
But do you see some code smells, you know, if they're going beyond 20 or 30 or 100?
Oh, sure. I think Netflix is a classic example of that. I think they have thousands of microservices. Google, another, you know, all the big .coms all have thousands of microservices.
Okay.
They've also, there's a lot of talk that Netflix specifically has done about there's such a thing as way too many microservices, you know, and that's where this domain focused thinking concept came through is let's make it intentional. Don't just split it off into a microservice because you felt like it.
Sure.
Any other brave souls?
Everybody good? Well, Schuyler, as always, thank you so much for doing this. We will load this up on our YouTube channel. It will be available. It'll also be available on irtalent.com. So we'll be pushing this out. And then if you want, Schuyler, if you want to send me the deck, I can get that out to everybody as well.
Will do.
Well, awesome. Well, thanks again for everybody joining. If anyone wants to kind of chime in locally, apparently we're going to be featured on the news tomorrow at 9:30 because of these things. So it's really awesome. Again, appreciate everybody's support and attending these. It's been fantastic, but hope to see everybody next week. But thanks again, Schuyler. Talk to you soon.